What is the future of robotics and ag tech? Hello and welcome to TechFirst. My name is John Koetsier. Everyone who's paying attention knows that ag tech is massive right now. There's so much innovation from laser equipped weed killing machines that keep chemicals off our food and out of our lands, to drones, autonomous tractors, AI powered seeding and watering plants, all that and much more. What about robotics? To chat, we have Kevin Dowling. He's the managing director at Robotics Factory in Pittsburgh, Pennsylvania. He's a former scientist at Carnegie Mellon Robotics Institute, serial entrepreneur, former VP Innovation for Philips. Welcome, Kevin.
Thank you. Good to be here. Thank you very much, John.
It's good to have you here, and maybe let's just dive right into it. Is the future of robotics in ag tech, does it come on wheels, legs? Does it fly? Does it swim? All of the above?
It's definitely all of the above, and I think it's ironic in that, of course, it started on legs with people and then animals, and then
Yes.
it went wheels and tracks. So almost every form of locomotion there is, maybe not serpentine, but certainly a lot of these others. So I
Oh,
think that there will be all of the above.
yeah, that reminds me. I think the word robot comes from the Czech and it means worker or something like that, right? So
Yes, it
yeah,
does.
we have been our own robots, sometimes compelled in history, sometimes not. Fortunately, not so much anymore today. But where do you see the most interesting innovation? Because I've seen some cool stuff on wheels and that works in the farming environment. And you've got massive, hundreds, thousands, tens of thousands of acres sometimes. And so big machines that can do big jobs. There's a role there. But there's also probably some roles that something that looks more like a human could do as well.
Potentially, I think most of it because of the size and scale of the fields, and also the equipment often either requires you carry a significant payload or that you gather a significant payload, tilling,
Mm,
seeding, harvesting. And the machine, like the human, would touch the field anywhere from a half a dozen to 30 times a year across the growing season. And so you need to have machines that can handle that. And today, for the more automated aspects of farming, literally standing in their field, it's tended to be row crops, the wheat,
mhm.
corn, soybeans, and so forth, where you have very large acreage of thousands of acres at a given farm field, especially in the Midwest here in the US. And so that tends to drive that approach to very large machine that can cover 12 or more rows at a time.
Mhm.
And that happens all the way through harvest when you have combines that do, everything at the end. Um, but what your fundamental question is, what is the configuration, the morphology of these farming machines? And it can be everything. Whatever's best
Mhm.
suited for that particular job will likely win out.
Mhm. Yeah. It's also interesting because, like you say, the big machines, the massive tractors, combines, it makes sense given the scope and scale of North American farming. Maybe a little bit different in Europe, maybe a little bit different in Asia and other parts of the world as well. But certainly in the States and in Canada, the massive farms there. It's
That's right.
interesting. It it's interesting when we see this explosion of humanoid robots. Do you see that coming into farming in any way, shape, or form?
I think it's interesting the anthropomorphic nature of humanoid robots is attractive because it's what we are, what we resemble, and what we look like. How do we uh, reconcile that with the job to be done? So, for example, I'll push back on that a little bit to say, if
Mm,
you were designing a dishwashing robot today, would it be humanoid, and why? Where we have this very efficient box that we put dishes into, and that's a robot for cleaning dishes. So why would we bother with the humanoid form if we don't need to do it? And airplanes don't necessarily mimic what birds do. So although the humanoid is trending right now in terms of robotics investments and so forth, it's not clear to me, as it wasn't with some of the walking dogs and other things that you see, all over YouTube, for example. um, but they are compelling because they look like things that we know. And
mhm,
a large, you have mentioned here the laser weed killing robot, which looks like something from space. Um, and hopefully it won't scale so big that it'll become a threat. But it's fascinating to see that. I'm not convinced that a humanoid robot necessarily will be what you need in order to do tilling and seeding and harvesting and so forth. But I think I will say though that for smaller farms who cannot afford these large autonomous vehicles, the big autonomous tractors, there's a real opportunity there because most farms, well, the US tends to much larger farms overall, but you mentioned other places around the world where uh, these types of machines could be used on
Hmm.
smaller farms if
Hmm.
they were affordable. So I point to a
Hmm.
company, the big ag equipment makers. John Deere leads the pack, but you also have AGCO, CNH. But then rapidly rising behind them are companies like Kubota or Mahindra. Mahindra is now the world's largest tractor manufacturer by unit
Wow.
numbers, not by revenue. So they're shipping more units to more farmers than anyone in the world. So where does that come from? What kind of technology can they add? What simple improvements? And the computers and the sensors that are added to these machines are lowering in cost every time. And I'd add one. You pointed out that robot has derived from the Czech word for serf or worker. The computer is the same way. The first computers were human. They were typically
Mm.
women in World War II who were actually calculating things all the time. And then that gave rise to the name, which was then applied to the Inhuman, right? The vacuum tube based large computers of the past, and then became the canonical name for calculating devices and obviously the computers we use today. But there's a lot of room for all kinds of machines.
Absolutely, absolutely, and that's always the tough point, right? Like, if you're going to build a robot for washing dishes, hey, the dishwasher is pretty freaking good, right?
Yeah.
On the other hand, it can't load itself. On the other hand, it can't empty itself. Now, you could build in things for that, and the question is, do you build in do you build 25 different types of robots that can do every task? Or do you build one that can sort of do what we do and make it work? And there's no right answer or wrong answer to that, but certainly in farming, it with the big machines that you need, you can totally see autonomous tractors, and they're here already to some extent, right? Um, being a thing. I guess one of the challenges, and you're in the business of finding, supporting, growing startups in ag tech and related fields. That's not cheap if you look at the size and scale of those machines. That's not the hardware startups are notoriously challenging,
Yes.
right?
Yeah.
I'm more used to software startups personally, right? But when you get into ag tech and you look at the size and scale of these machines, the jobs they need to do, the amount of funding required must be significant.
It is. I think any hardware based company has a greater challenge than simply writing good code to solve a particular problem. The advent of a large machine, but even I'm not sure that the scale of the device matters so much as the ability to do the controls and everything. In other words, if you're making a new, let's say, like go back to the Nest or an Apple Watch, very complex small mechanisms, but the scale of that device matters less than the complexity of the thing you're trying to put together. So a tractor is typically an engine. Today, sometimes you'll find an electric motor and a drive, and those are well known, well understood, and made by in the millions today across the planet. Um, but to your point, testing requires larger areas. You need real estate to do that. Sometimes it has to be seasonal, so you can only do it at certain times of the year. So that only compounds the challenges. But there are many small companies focused on ag and doing it today, whether it's mowing or forestry, all the way through row crops, specialty crops, and livestock. Not so much, but there is increasing automation, even in livestock, beginning with milking parlors for dairy and other things that people want to do. I've talked to investors who want to invest in things that are heavily manual today. And the most heavily manual today still requires people to process animals into food.
Mhm,
So
mhm.
if you're looking for a protein source like that, there are many concerns around being able to manipulate and use the tools that they use in order to turn animals into food.
Hmm. Hmm. What are some of the more interesting startups that you're seeing that are coming across your desk and maybe that you're investing in?
So there are about a half a dozen here in Pittsburgh right now. One is focused on vineyards and monitoring vineyards, as well as doing harvesting and so forth. One of the most interesting things that I've seen is that if you think about grapes, for example, normally if you just let them grow, they would become these scraggly sort of bushes, but they're essentially trained to wrap a structure and then form a particular thing. They're not doing that with apples. They're doing that with other crops too, so that you can change what is in the field, either potentially genetically, but the other way to do that is to simply provide a structure that they can grow in and around, making it more accessible for automation, more easy to use. But it also makes it easier even for the human to do that. To reach the top of a cherry tree or an apple tree typically requires a specialized ladder or other equipment, or sometimes you can find these really interesting videos where they have shakers that come up and grab the trunk and shake the entire tree, and that's how they harvest. Um, so all of that, I believe, could be automated, whether or not you use entrainment of a plant, or you create plants that are genetically easier to harvest or produce an apple, for example, that is tougher and able to be shipped and stored and then eaten eventually. Um,
Mm.
so there are companies like that. We have graduates of the programs here in robotics at Carnegie Mellon, for example, in Pittsburgh, who are off doing these types of things elsewhere.
Mm.
We also have a company you mentioned earlier, the idea of indoor agriculture. Um,
Mhm.
the idea is you have more than a greenhouse where it's actually set up to be fully automated. And we have a company here for growers, which is harvesting tomatoes in greenhouses. And they're doing this in not only here in the US, but in the Netherlands, which is a hotspot of indoor agriculture, as well as, excuse me, as well as automated agriculture. And they're harvesting tomatoes rapidly.
That's really interesting because a lot of tech comes out of the Netherlands because they've vastly expanded their agriculture on a tiny land footprint. So they've gotten very sophisticated at getting high yields and high automation because their costs are high and everything like that. Obviously in flowers, but also in agriculture.
That's right.
Super interesting that they're taking their tech to the Netherlands. That's pretty cool. Farms are a crazy challenging environment to put robotics into, right? I mean, they're complex, they're changing, they're moving. It's not laid out like a factory. It's not relatively stable. Ground conditions change. There's weather. There's
Yes.
animals,
Yeah.
right? And every type of farm is different as well. A wheat farm is very different from a vineyard, as you mentioned, or a
Mhm.
beef dairy concern, that sort of thing. That leads to significant challenges, I'm assuming.
It does. It's not entirely unstructured. It's not a walking into the woods, for example, where you have no control of anything, but it is, even though it is slightly structured, it's still challenging. It's soft materials that you have to traverse. You're also some big concerns right now in agriculture have to do with soil compaction. So how do you prevent that from happening as time after time as these machines sort of roam these fields? How do you prevent those kinds of things? Well, you can make them bigger, have softer tires, more legs, perhaps, depending on the approach. And the farmer is assuming most. In some cases, I think people are arguing all of the risk because they face those challenges. It's outdoors, and you're subject to all of the vagaries of the outdoors in general. Um, so they get the harvest time and they produce the crop. But if they had bad weather, if they had floods, if
Mhm,
they had drought, they're the ones assuming the risk. So how do we help the farmer to mitigate that risk? One way, as I mentioned, is moving indoors, but who knows? There can be other potential ways. There are crops, for example, that can be grown entirely indoors, like mushrooms. And you and others might be amused by the fact that mushrooms are a crop, but they are, and they harvest every several weeks. It is actually Pennsylvania's number one crop by volume, by dollars. It's
wow.
well, $600 to $700 million a year to the state of Pennsylvania.
Wow.
So if Pennsylvania was a country, it would be number 4 in the world in the production of mushrooms. But very likely the mushrooms you have on your pizza or in your salad are made right here in Pennsylvania. But they have
It
problems harvesting because of labor issues. So how do you solve those?
Yeah, yeah. It's interesting that we had the discussion at the top, like, what is a robot? What do you classify as a robot, and what's the most efficient sort of machine, whether you call it a robot or not, to operate on a farm? We talked about bringing farms indoors. Vertical farms are a thing,
Hmm.
right? And there's huge potential there for year-round production, right? There's huge potential there for production where it's needed, so right in the city, let's say, or nearby, or production for, let's say far northern climates, the Alaskas of the world, right? Where farming is not really a thing. It's kind of a thing, but it's not really a thing, but fresh
Right.
fruit and vegetables are required. In that case, the farm itself is a giant robot. That's an
Yes.
interesting world to consider too.
Yeah, it is. We have a rather broad definition of what robotics is, and I think of it as the cycle of sensing, uh, planning, and actuation. And so you take that loop, that triumvirate of these three aspects of it. One is capturing the data, planning based on the data you've acquired, turning that into information, and then turning that into potentially movement. It doesn't have to be movement, but a thermostat in your home also follows that same cycle these days. It's not necessarily a robot, but to your point, John, the idea of a home. I think a famous architect like Corbusier said, a home is a machine for living.
Hmm.
And I think we're living inside of robots because our climate is controlled, our temperature, humidity, many other things about our home, the lighting, everything can be controlled. And so that's an environment that we've created for ourselves that is robotic in nature.
Hmm.
Uh, but agriculture, I think, can be exactly the same type of cycle, the exact same type of thing where we're trying to control things in order to produce food or do
Hmm.
some task in a factory, for example.
Hmm.
But
Hmm.
all of those loops together. So I think your analogy of the farm being a robot is exactly spot on.
Is there Is there progress, or are there even projects to create something like a farm OS? Because let's say, we're 5 years in the future, 10 years in the future, and you're starting to see a significant surge of automation and robots and semi-autonomous machinery on farms. There's a command and control issue, or there's at least a work together issue, right? And do these things know about each other? And do some of them cooperate? And some of them are harvesting, but then some are gathering and transporting. And do they talk? And how's that communication? Is there a project underway to sort of manage that? Or is it basically using um, some of the operating systems that people are developing for coordination of robotics in general?
I think most of it is exactly your last point, which is using real-time operating systems, for example, or using ROS, robot operating system, to control the robot itself. But in terms of complex networks of robots, there's not a whole lot of work going on in that area. I do think it will be absolutely necessary to do that. If you have, if, I, I believe that there will be a trend to move away from the very, very large machines, the $500,000 12 row kinds of systems to larger numbers of small machines, which are more easily maintainable. You can pull them out if you need to. And by having a larger number of smaller machines means that they do have to communicate. They do have to know where
Mhm,
each other is. And that will
mhm,
require, as you pointed out, the ability to communicate amongst themselves, like a mesh network in a way, but mobile, and being able to coordinate and synchronize their operations. If you think about it in a field today, even the operation of a harvesting, let's say you're moving through a field of corn. The U.S. has around 90 million acres of corn, so there's a lot of it. Um, but as you're harvesting, threshing, as you're generating the grain and the cobs and so forth that are becoming eventually silage or other things, um, there's a coordination of vehicles, one
Mm,
driving to capture that flood of granular material coming into one vehicle from another. And
mhm.
so there's already a little bit of that work, but typically one and twos, not tens and twenties of these machines working together. Sometimes you'll see these wonderful, beautiful pictures of probably Kansas or further north, where they're row after row of combines working together, and then
Yes.
they migrate. Those aren't robots yet, but they essentially migrate northward with the harvest, and that's a
Yeah.
specialty machine that allows farmers to harvest a great deal more quickly, and because they can't afford that many machines, no one really
Yeah.
can.
Yeah.
Uh, but as they move north toward Canada, it allows them to do it at a rate that is far faster than anyone could do in history prior to that.
Interesting, super interesting robotic migration. Here we come. Very cool. Do you do any investing in, I want to say farming adjacent areas? Because there's a lot of work. Let's say we don't want to have however many tens of millions of cows that there are in the United States and Canada, and we don't want to kill that many for food. And so we want to grow beef and have the Impossible Burger and other stuff like that, lab
Hmm.
grown meats and other things like that. Do you do any investing in those areas?
We haven't. I think that's probably a little beyond our direct knowledge and capability. I have nothing against that. I think creating protein sources like meats from certain chemicals is certainly a valid way to do that and reduce some of the impacts that the full animals have. But I'm not especially um, uh, going after one versus the other.
Hmm. Hmm.
Um, but perhaps one way to think of this is there's the farm, and that's really what we focused on in our recent AgTech summit, which is specialty crops and row crops. But we did ignore, for the purpose of this particular summit, livestock,
Hmm.
pigs, chickens, cows, and so forth, cattle. And then at the beginning, there's also seed, fertilizer, chemicals, and other things. And there are ways now. There's one company here called Robot, and it's spelled ROWBOT. They're focused on small robots going between rows of corn, which happen to be planted perfectly on center, 30 inches apart. And so
Hmm.
they designed a robot to do exactly that and inject nitrogen directly at the roots of the plant.
Hmm.
So it cut the use of nitrogen, which has other impacts in the environment, of course. It
Hmm.
ends up in the
Hmm.
Mississippi River. It will then make its way to the Gulf of Mexico and so forth. But it cut the use of the nitrogen fertilizer by half,
Nice.
which is not only a great cost savings, but it reduces that impact on the environment substantially. And they've been working with
Absolutely
that for
huge.
quite a bit in hundreds of acres in Iowa right now.
Absolutely huge. If you look at the amounts that farmers spend on fertilizer, I mean, you have obviously, it
Yeah,
blows your mind. I mean, there's huge costs here. And like you say, and nobody wants all that flowing into the lake and all
that's
the
right.
algae that comes and everything. Right. So, yeah, exactly. Okay, let's look forward. What does farming look like in, let's say, 10 years? As we see more purpose-built robotics and machinery, autonomous machinery for the farm. What does farming start to look like?
I think it's certainly an extension or an extrapolation of what we see today. There will be more machines in more fields doing these types of operations. At the beginning, of course, there'll be the much larger farms which can afford this machinery, or perhaps there'll be some interesting ways to financially incentivize the farmers to lease these things, capital lease, operating lease, all kinds of financial ways to manage that to further it. Um, and then I think you'll begin to see taking that same technology, which will get cheaper, but once it's become solid and robust in terms of use, you'll start to see that on smaller farms, where if you have not 20,000 acres, but 2,000 acres, you can also make use of that. I don't know how much smaller it will get if you have 20 acres or
Mhm.
2 acres of farm. Will it have autonomous vehicles? Yes, eventually. But and you asked about the next 5 to 10 years. I'm not sure that it will, but I hope that it will.
Mhm. Hmm.
And so those are the field operations. And then there could be things related to fertilizing and inspection. It could be drones and other things to sort of monitor crops, look for disease, basically remove those that are diseased from the field. And all of that could be done in an automated fashion. What's interesting to me too, a lot of what we learned was post farm. When you go from harvest into the processing chain, there are a lot of interesting both economics and potential automation. So, for
Hmm.
example, we've seen many across the country. I'm sure where you are, and certainly where we are in Pittsburgh, the rise of many small breweries. But
Hmm.
very often they can't scale well because for a small amount, you have the machinery and the existing industrial tools to be able to satisfy a brewery's output, which might be, who knows, a thousand cases a year or something like that. But when you start to scale beyond that, there's a gap actually in the market between what a Nestle can do or a very large food company can do and what a small growing bakery or other things. So there's an interesting gap in there. We've been talking to contract manufacturers who work in that space about how to improve that. And there may be room for another summit related to post farm activities and food processing.
Hmm.
So,
My hope is also that in whether it's 5, 10, 15 years, as this becomes more available to farmers, this technology, we also have a better product. We also have better
yes,
food. We use less fertilizer because it's as you mentioned, injected right where it needs to be, not just carpet bombed over the farm, right?
right.
We use less pesticides because we have machines that either mechanically or with lasers remove them. Stuff that we're seeing right now, but isn't necessarily widespread, right? And maybe we have less waste because we're smarter about how we harvest. Maybe we lose less to crop failure because, as you said, there's constant monitoring, perhaps drone based or something like that, so that we can identify, oh, there's something attacking the corn here. Let's get rid of that. Let's treat that right away, and it won't spread. So my hope is that farming becomes safer for humans, but also better for the environment, and also better for people who like to eat food.
Yes, I certainly have the same hopes and dreams around that. Organic farming, for example, there may be a lot of ways where machines can help grow, not no pun intended, grow that part of the market as well, where we could have healthier food that's grown. And here's another aspect of it is, everybody sees farmers markets. You might see the honest stands where you basically
Mhm.
put money in a jar and you take a dozen ears of corn. Um, there might be ways to do monitoring of that to reduce the need for people to be there all the time.
Mhm.
And then you have companies like one here in Pittsburgh called Harvey, Harvie, where they're going directly from the farmer to the customers. So they're able
Mhm.
to navigate. They work with something like 300 to 400 different farms. So that's another link in the chain of being able to provide good food for people on a timely basis where they can they're essentially directly paying the farmer. There might be a
Mhm.
middleman in there doing some of the distribution, but I think I think hesitate to use this term since it's used so often, but the democratization of farming and how to get it so that the farmer can benefit more directly from it without a lot of processing and other things going on in between them and the consumer. It's really opened my eyes to see all of this. It's amazing.
It is amazing. And like you, I also hope that these innovations will come down to the smaller farms because we've seen some interesting, amazing, incredible things in small farms right now, even as small as 1 acre on like a city lot or something like that,
Mhm.
where with intensive farming techniques and there's really a lot that can be done. Want to thank you for taking this time. Do appreciate it.
You're welcome. Thank you, John.